The next part of Chapter 8 we're going to talk about is something called scientific notation. So by the end of this lesson, you should be able to simplify expressions that are in scientific notation. So think back to your science class. Sometimes you deal with either really, really big numbers or really, really small numbers. And scientific notation is just a way to write those numbers without writing out tons of zeros and taking up a lot of space. So a number in scientific notation is written as the product of two factors in the form a times 10 to the n power, where n is some integer, and this part's really important. A has to be some number in between 1 and 10, and it can't be 10, can't be anything bigger than 10, so like 9.9 works. So here's some examples. These numbers here are all in between 1 and 10, and these are integers. And this just tells you how to move the decimal. 3.4 times 10 to the 6 means 3.4 times 10 6 times. And we could write this out 6 times if we really wanted to. But you know, every time you multiply a number by 10, you end up moving the decimal and making it a bigger number. Same thing over here with the negative 10. Remember, a negative exponent means that you're going to divide. So we would divide by 10 times in this case. So let's just practice our numbers written in scientific notation. If not, explain why. So you're looking at this number here. Is it something between 1 and 10? And yes, it is. And then you're looking for this number here to be an integer, which means it can't be a decimal or a fraction. And because that is, yes, this number is written in scientific notation. And then the next one. This guy right here is not a number between 1 and 10. So this whole thing is not in scientific notation. Same thing with this one. This number is not in between 1 and 10. This number is okay, but because of that, this is also not in scientific notation. So let's just put some numbers in scientific notation. So let's start off with this big number here. Remember, we have to move the decimal so it's someplace that makes it a number in between 1 and 10. So every number starts with your decimal place over here. And we're going to move it 1, 2, 3, 4, 5 times, because if we put it right there, 2.67 is the number in between 1 and 10. So it's going to be times 10 to the, we moved it 1, 2, 3, 4, 5 spaces. And keep in mind, this is a big number, so this exponent should be positive. Let's skip over here and do C. We want to end up with the decimal point right here because 3.25 is a number in between 1 and 10. So when we go to move the decimal for this one, we're going to move it over 1, 2, 3, 4, 5 spaces again. But this time, because the number is small, we want to divide by 10 5 times. So keep in mind, this one we moved it to the right, so it's a negative number. And this one we moved it to the left, and it's positive. So let's look at some numbers that are already in scientific notation, and let's put them in standard notation or normal notation. Let's look at B. I'm looking at this, and the first thing I see is that this is positive, so that means I'm going to get a big number out of this. So you start with the number they give you, and we're going to multiply it by 10 4 times, which means I'm going to move the decimal over 1, 2, 3, 4. And then we're just going to plug in zeros for these holders right here. So this number becomes 50,700. And then let's look at the next one. I see a negative number here, so I know I'm going to end up with something small. The decimal starts in between the 5 and the 6. I'm going to move it over 1, 2, 3, 4. And just like before, I'm going to throw some zeros in there. So this number ends up being 0.00056. So the next thing we can do is order numbers in scientific notation. The following masses are parts of an atom measured in grams. Order these parts from least to greatest. So the first thing you have to look at is their powers. Because all of these are negative, that means that these are really, really small numbers, which makes sense because we're talking about neutrons, electrons, and protons. Something to the negative 28th power is going to be way smaller than something to the 24th power. So an electron is going to be the smallest. And then when numbers have the same power up here, we can just compare these guys. So the next smallest is going to end up being the proton, because it's 1.6726 times 10 to the negative 24th. And then finally the neutron. Oops, that's a 4, 9 times 10 to the negative 24th. So make sure you pay attention to the powers, and then once you've ordered the powers, you can pay attention to the number out in front. So we're going to do some operations. If you just multiply a number by something in scientific notation, you just multiply that number by the number part, not by the power part. So 2.5 times 6, all we have to do is multiply those numbers together, and you end up with 15. And then this part stays exactly the same. Now this is not in scientific notation, so what we need to do is take this 15 and put it into scientific notation. And this would be 1.5 times 10 to the 1 power. We move the decimal over 1, but then remember it's times 10 to the 3rd also. So then we have to use our rules. Our rules say that we have to add our exponents when we are multiplying. So that's our answer. I want you guys to try that one on your own. Now sometimes we multiply numbers that are in scientific notation by other numbers that are also in scientific notation. So this one's kind of like what we've been doing in class. You multiply the numbers together. So 2.5 times 6, we just did that, is 15. And then it's always times 10 to the something. So we're multiplying 10 to the 8th and 10 cubed. So again, use our rules. We're going to end up adding those exponents. And then again, we have to put this into scientific notation. So 15 is 1.5 times 10 to the first power. And then we still have this over here, times 10 to the 11th. And then we just add our exponents once again. So this is 1.5 times 10 to the 12th power. Let's do the last one. Remember, you multiply the numbers together, so 9 times 7 is 63, times 10 to the, add your exponent, so negative 6 minus 9 more is going to end up being negative 15. We have to have our answer in scientific notation, so let's move this. This becomes 6.3 times 10 to the first power, and then we still have times 10 to the negative 15. So when we combine these exponents and add them, we end up with 6.3 times 10 to the negative 14th. And then the last thing that you'll be asked to do is divide things with scientific notation. And just like before, you divide your numbers, and then we use our rules for the exponent part. So 2 divided by 8 is 0.25, it's 1/4. Times 10 to the, use your rules, we need to subtract, so this ends up being times 10 to the negative 5th. And just like before, it has to be in scientific notation before we're done with it. So when we convert this, this becomes 2.5. Since we had to move it to the left, this is going to be times 10 to the negative 1. And then we still have this part, times 10 to the negative 5. So just like we've been doing, use your rules, add them together, and you get 2.5 times 10 to the negative 6. Let's try one more. Remember, divide the number part. So 2.5 goes into 7.5 3 times. And then it's times 10 to the, use your rules, which says we get to subtract those exponents. So if we do 12 minus a negative 4, we're really adding, so that's times 10 to the 16th. And that's it, we're done. This number is in between 1 and 10, so we don't have to do any moving around. So there's a couple problems that we didn't do in the video. Go back and finish all of the blank ones. Prove that you can simplify expressions in scientific notation. Make sure you write down any questions if you have them, and we can go over them in class. Enjoy your night.